Elon Musk has raised the bar once again. While Tesla cars are famous for their magnificence and potential, this new engine is revamping the EV industry. What precisely does the new powertrain entail, and will it dominate the automobile industry? Join us as we unravel how this insane engine will modify all the EV cars. The most important Tesla vehicle. Since the first Model S with a 265-mile range was revealed in June 2012, 250,000 Teslas have been sold. Since its introduction, the Model S has been recognized as Tesla's most important vehicle. Consumer Reports discovered that the high-tech all-electric Tesla Model S provides excellent performance and a great driving range in 2013 to 2014 model year testing. They were on to laud the Model S, calling it the finest vehicle they had ever tested. It was not the end of the story though. The story has just begun. The 2013 Tesla Model S was named Ultimate Car of the Year by Motor Trend staff and judges in a rating spanning the publication's 70-year span. The Tesla Model S received a makeover in 2021, about 10 years since its first debut, to much praise. Tesla has boosted the performance for both range and speed, with a rebuilt motor in addition to a revised appearance and renovated interiors. Elon Musk is ready to shake up the existing quo in vehicle engines. Previously, if you wanted to become electric, you'd have to transport a large number of batteries, but nobody wants a large and bulky vehicle. Because of this, developing a high-performance electric sports vehicle is extremely difficult. Tesla then began working on reducing the motor's size. Cooling is a significant reason why engines are so large. It takes a lot of space to distribute cool air around all of the metal. As a consequence, Tesla began to consider how to build a motor made entirely of solid metal with no moving parts or cooling components. They accomplished the seemingly impossible by developing a model that was both quicker and heavier than previous models. The mechanism of a Tesla EV. As a result, the new vehicles could move faster than previous versions and manage better over crazy torque curves. They had a substantial influence on the automotive industry. This new motor is both more robust and lighter than the previous model. According to claims, the Model S can generate maximum torque faster than its last version. An exciting ride is provided by the astonishing rapid acceleration. The engine in Model S is claimed to be faster than the previous generations in terms of reaching maximum torque. Astonishingly, quick acceleration provides for a thrilling ride. Do you understand how these electric cars work? Well, this happens because of a magnetism and the natural interaction of electric and magnetic fields. Electronic fields are formed when electrical connections are closed and electrons may move through them. They have north and south poles. This is because when there is another magnetic field, opposing poles attract each other, but similar poles repel each other. A case containing two pairs of magnets and electromagnets surround the shaft of an electric motor. The motor generates torque and ultimately moves the wheels by changing the polarity of one pair of electromagnets regularly. These magnetic electromagnetic forces, like regenerative braking, may convert motion into electricity. Well, what current is supplied to your house? Alternate current, AC. The electric supplied to your house is known as alternating current, or AC, because the polarity of the power changes or alters 60 times every second. In other words, 110-volt AC is used in the United States and other countries, although 50 Hz AC is widely used in nations having a 220-volt standard. Each battery's plus and minus poles are driven by direct current, or DC. As previously stated, alternating current is required to turn motors. If there were no electromagnetic forces, they would just lock their north and south poles together. A motor continues to run by its north and south poles rotating. Alternating current, or AC electricity, is the most efficient technique for transport energy from a generator over long distances, such as a dam or windmill. Because of the alternating structure of the signal, it is feasible to easily modify the voltage when utilizing an AC signal. Tesla favors alternating currents AC to direct currents DC for automotive power because it enables them to design significantly more effective generators, motors, and electrical distribution systems. Technology is rapidly progressing, allowing electric cars to catch up to and potentially outperform gas-powered automobiles. For the time being, progress achieved by firms such as Tesla in the creation of electric vehicles offers cause to believe that transportation will no longer be dependent on fossil fuels in the future. The Tesla Model S sedan has a range of up to 288 miles, a top speed of 155 miles per hour, and a torque of 687 pounds per feet, making it one of the most powerful electric automobiles on the market today. The driving range and battery life of Tesla. Tesla distinguishes itself from the competition with its uniqueness. It makes innovative products that no other company makes. The EPA estimates the Tesla Model S Long Range Plus's maximum driving range to be 402 miles. This is an improvement of 87 miles over the vehicle's launch in 2016 with a 100 kilowatt-hour battery. To reach this aim, Tesla produces its motors, inverters, battery packs, and other components, rather than relying on a Tier 1 source. Tesla can continuously increase the performance of these parts by using this do-it-yourself technique. The battery is the system's heart. In contrast to Audi, Toyota, and Mercedes, you may use the full battery pack when driving a Tesla. This implies that in the case of the Model S, the user has access to the entire 100 kilowatt-hour capacity, rather than merely a fraction of it for its battery life. According to a Tesla engineer, the business has always given the whole battery pack in all of its vehicles. Other automakers have assured that backup cells will be accessible if a battery fails. The Audi e-tron, for example, has a 95.3 kilowatt-hour battery pack. To be clear, this is the bare minimum. The battery's real useful capacity is 86.5 kilowatt hours. Tesla believes that the capacity of the battery pack varies somewhat as well. According to the firm, a Model S battery has a capacity of 100.0 to 105.0 kilowatt hours. Even after using 96.2 kilowatt hours and traveling 0 usable miles in your Model S Long Range Plus, the battery still has 6.3 kilowatt hours of energy left in it. Tesla claims that the technology is designed to function similar to a fuel tank with a reserve. When drivers are given the entire software at once, battery loss becomes more visible. When cells quit operating, there's no buffer. Tesla guarantees at least 70% of the battery's capacity for 8 years and up to 150,000 miles. A greater driving range is achieved by reducing waste in the engine. A more energy-efficient motor can run for a longer amount of time. Inefficiency of motors. In EPA testing cycles, the efficiency of the AC Model S motor has increased from 80% to 90%, with a peak efficiency of 94%. According to Tesla, increasing motor efficiency by 8 to 10% will enhance the range by 15 to 18%. Tesla also claims that its inverter is 96 to 97% efficient. The invert's maximum efficiency is roughly 99%. You must still convert AC to DC when utilizing level 1 or 2 chargers. There wasn't any mention of this efficiency, which is depending on your local electrical infrastructure and is far lower than Tesla's existing vehicles. Between automobiles and the network, both routes of communication are feasible. Tesla has made software improvements using anonymized data from its vehicles. In the future, it will be able to track a big number of automobiles and utilize that data to enhance both software and hardware. As a result of all that tweaking and testing to extract every last ounce of energy from components, many of the vehicle's members must be created in-house. Tesla's vehicles must be developed and maintained to be efficient. Traditional automakers have traditionally been hesitant to enter the changing market. Tesla, on the other hand, built its supercharging infrastructure. Tesla's supercharger. The term that constructed the vehicle's charger also built the first supercharger station. In comparison to the original supercharger, the new Model S can get a range of 160 miles in 15 minutes. It's hardly unexpected that Tesla promised quicker charging with the new Model S. The current V3 supercharger, which has a maximum output of 250 kilowatts, is compatible with the Model S, Model X, and Model 3 variations. As a result, either a V4 supercharger or a V3 upgrade will boost charging speed. The Model S and other future Tesla vehicles are planned to have charge rates of more than 250 kilowatts. Electric car options may grow as technology advances. Electric cars, on the other hand, look to become more reliable in the coming years. Pricing at superchargers varies depending on location. However, it is normally around 25 cents per kilowatt. A complete recharge to around 250 miles of range would cost around $22. Will Elon Musk be able to dominate the EV industry with this model? Write yes or no in the comments section below. If you enjoyed this video, don't forget to subscribe with all notifications turned on. And if you want to see more interesting videos, click the video on the screen now.